So for today's session, I'm going to jump straight in. We've got a lot of ground to cover. 2026 is year. We've had a fantastic few years. It's 11 years of FDL this year, and really excited to see what's going to be coming up. Very briefly, a bit of an agenda for this afternoon. So some brief words of welcome and introductions. Then I'm going to jump straight into FDL and Earth Systems Lab 101. This is a very general, quick overview of it. We'll cover quite a lot of ground. Don't worry, the slide deck and the recording will be made available afterwards for you to refer to. And then we'll dive into some of the practicalities of Earth Systems Lab 2026, what that looks like. This is obviously in conjunction with the sister programs, Helio Lab and Lunar Lab, and the possible additions of Flight Lab and FDL Med. Then I'm very happy to be joined by Will Jones with us this afternoon as a FDL alumnus, both researcher, faculty member, and absolute legend all around, for some reflections. I will then end with the application information, some Q&A, and I realize that is probably what most of you are here for. So we'll go through to that point as swiftly as possible. I'd love to encourage all of you to engage with this session. It is very much for you folks to be asking the questions. To do this as efficiently as possible, we're going to be using the Q&A function on Google Meet. So for those of you who don't know or not too familiar, if you look at the bottom of your screen towards the right hand side, the 9 little dots, that's pulls up a general menu, and you will see a Q&A option right there. So give that a click, and maybe as a start, I'll just ask a question, and it can be something as simple as, where are you dialing in from? And as you see, when one posts a question, you can upvote as well. So please use this functionality throughout the call today, and upvote the other questions that you feel would be something you want to know more about, and we'll cover that. So where are you dialing in from? I'm just going to pick on you, Will. Then we can answer that question and get that out the way.
Yeah, I'm dialing in from Edinburgh, working from home this week, which is quite nice, although it's still quite cold up here. February in Scotland is not the best weather.
Oh, I must admit that my sound was a little bit poor there, but that might be on my side. So I'm going
Hopefully
to
mine, that's okay.
set off. But okay, I'll make sure that that's sorted out from our side with some sound. But let's make a stab at this going through. So some brief introductions. I'm Mike Haynes, so program lead for FDL on the Europe and UK side of things. So that's in particular Earth Systems Lab. This is the partnership with ESA, and focusing more on the Earth system. And joined this afternoon by Will Jones, as I said, initially a FDL alumnus from a number of different challenges, but both from a researcher perspective and a faculty member, and now a research fellow at ESA as well. So just to set the scene about FDL, I realize quite a few of you have heard of us before, but the real question that we ask every year is, can we do world-class AI research over the summer? Can we differentiate ourselves from just being a typical lab, say in a university, and really progress to impactful outputs in a very short space of time? And the answer is a resounding yes. It's been 11 years of doing this together, And the real question that I would be asking you is, what research would you like to lead the world in over a summer period, over a summer sprint? We have a number of different programs. So for today's session, information session, it's very much focused on Earth Systems Lab. So this is in partnership predominantly with ESA and focusing on the Earth system, everything from climate extremes to crisis response. There are also other partner labs, and for completeness, just to run through them, there's Heliolab, which is a partnership with NASA focusing on heliophysics and space sciences, space weather, the impacts of that on our operations in the near Earth space environment as well. Then there's Lunar Lab with the Luxembourg Space Agency focusing on lunar science and lunar resources. And then this year we are also possibly, fingers crossed, a new edition of Flight Lab and FDL Med, which has been around in the past. I'll also just say that we are in the starting phases, the kind of the precursor scoping of FDL Foundations Africa, which is a slight derivative of FDL, focusing on the deployment of foundation model capability in an applied sense in Africa. So yeah, we have a lot of different programs. This particular information system or information session is focusing on Earth Systems Lab. But if you are interested in any of the other programs, we will have another set of information sessions tomorrow and the next day for Lunar Lab and Heliolab in particular. But you can find out more about these on our website, fdl.ai. So basically what we specialize in is fusing subject matter specialists with data scientists and really tackle these big, challenging, open research questions. So set up as a challenge and then putting these ingredients into a beautiful container, which is the FDL Sprint, and really letting the magic happen. So it's all about interdisciplinary science. It's about bringing the best of academic rigor and industry best practice together and really doing as much as you can over quite a short period of time. But it's a very intentional, and I would like to stress that it's not just about the summer. FDL is about so much more. And what you end up getting out of this experience is also not just a great summer. So how do we do this? Well, we don't do it alone. The big thing that we sort of champion is interdisciplinary science, but also interdisciplinary partnerships. So bringing together industry and academia together, and this cannot be done without the support of the chief stakeholders, ESA, Luxembourg, and NASA, and then the compute providers, Google Cloud, NVIDIA, and Scan in particular, and additional ones as well. So yeah, we have seen some publicity from our friends at Google Cloud and NVIDIA, which is always great. And as I say, we cannot do it without their support. And as we know, it's become increasingly popular to be doing AI. It's not a new thing anymore, and there's a lot of competition for resources. So incredibly grateful for the support. So what do we do? We over the last 11 years, we've been using AI to answer these big open questions. But what does that mean? Well, we look at complex systems throughout the solar system, from the sun all the way to our Earth and the Moon, and we really want to be answering scientific questions. So there's a grounding in that sense. But it's not just about science, it is also about application. We do want to track through to a very clear and intentional big why. Why is this important, and why do we need to do that? So how do we protect our infrastructure and our communities in this changing world? Over the last 11 years, there have been a host of different firsts and different achievements. I won't dwell on this. I think having you all here join us this afternoon speaks for itself. it's fantastic to see a lot of the research that gets started within the FDL sprint goes on and matures and sees application in all sorts of different contexts. But yeah, it's this blend, as I've been saying, about interdisciplinary science from different domains, interdisciplinary relationships, and at the same time, the merger of a science and applied focus. In terms of where we are, AI is no longer new. It's no longer about just doing a single pipeline with your single data set and getting a paper out of it. I think we have all seen over the last 12 months how the shape of the things has changed significantly. And we really have been looking at this for the last few years. So we see ourselves not just doing AI for science, but we're doing AI infrastructure and orchestration for science. So no longer does one just think of this as a single sort of pipeline. One looks at all the different components that work together, the continual learning aspects of letting your model learn through time and stay relevant. Obviously, there are all the possibilities that have been enabled with foundation models. How do we take those though and deploy them on devices in the field? So there's the whole question of edge deployments. And what FDL does is trying to answer all of these questions together, no single component alone, and integration is key. And we've seen that with examples across the board, across the different challenges over the years. None of these are siloed as such. Each one can form a piece within this what one could call the sort of frontier intelligence stack of capability. And just to color this in for some of these examples, so a few years ago, one of the outputs from FDL was world floods, so near real-time flood segmentation from orbits, which really changes the way we can respond to crises around the world. So being able to do that as soon as possible and alert. So that's formed the basis of a whole bunch of operational models. Another example is StarCop. So this was actually a challenge that got extended last year. And the idea here is to be doing on board retrievals and identification of greenhouse gas emissions, in particular methane, and this pipeline has formed the basis of operational tool at the UN Methane Alert and Response System, or MARS. Another example of an operational output, an applied output from FDL, is the common thermospheric density estimation pipeline. So this is a pipeline that is looking at predicting the thermospheric density or the drag that satellites experience, and is something that is operational with partners at NASA, SW Trek as well. So a whole range of different applications that the initial concept was brought to life through a FDL sprint. But now that was all talking about the past. What are we going to be doing in 2026? The framing for 2026 is very much building the mission control of the future, and this is the mission control of the future for humanity wherever we are. So on the moon, with the impacts of the sun, and obviously planet Earth. So the real question is, what is the kind of the new capability that is needed in this mission control? And for Earth Systems Lab, the question is it a nervous system for planet Earth that we can start developing? And this idea of an integrated, orchestrated system with different challenges, not being siloed, but actually being able to speak to each other, is something that we are hoping to really explore in 2026 and take further. All those building blocks are very much there. So to speak towards that, and these are very much the starts of the challenges. They are evolving and being refined as we speak, but we really want to be moving towards this frontier intelligence stack and as many of you on the call would know, that's not just about AI sort of for science. There's a lot of plumbing involved. There's a lot of software engineering. There's a lot of very critical infrastructure that needs to be spun up in order to realize this vision of an entire stack that starts at perceiving, getting data in, processing, and all the way to planning, where you can get to decisions and insights. So for 2026, we will have 3 research challenges. At the moment, the kind of core focus of these would be to look firstly at a sort of an integrated intelligence stack, and that is thinking about sort of agentic reasoning for perhaps balancing a whole bunch of different model outputs. The example here is where you have biodiversity and carbon capture all playing a role within, say, economic trade-offs for a particular solution, and understanding those trade-offs in an agentic reasoning system. The next one is extreme weather and crisis response. So here again, it's looking to mature on some of the previous FDL challenges, and possibly, as this example, fusing sort of 3D cloud morphology with ocean and lightning data to be able to predict rapid intensifications of tropical storms and providing that lead time for coastal populations. And then, yeah, towards that sort of realization of onboard AI, really fast inference being possible. It's exploring that in a sense, and possibly adding filters to space hardware that can remove RFI and deliver that analysis-ready data directly from orbit. So there's quite a lot of interest from ESA side with regards to that. So that's kind of a feel for what is possible with the journey that has brought us here, and now into some of the more pragmatic aspects. So how does FDL work? I've been going on about that it is a interdisciplinary endeavor, that we bring together the right people, and hopefully a lot of you on the call would be those people. So how it's set up is that there would be research teams made up of researchers, and then a couple of faculty. The faculty are the sort of team leads that help guide the entire process. So would be coming on a little bit earlier and helping define the challenges themselves, getting some of the preparatory work set up. And then, yeah, there's the FDL support team. So there's myself, and on the call today, we also have Tom and Carmen, who you'll hear a lot more from. And we really there as the enablers and helping you all get the best work done as efficiently as possible. And this sits within this FDL community. So community of advisors, mentors, our compute partners, our industry experts that are incredibly generous with their time and are able to join us for reviews, these sorts of things. And bringing all of these elements together in a very well-defined and intentional process, we can get incredible things done. I've been saying things along the lines of it happens over summer and there's a bit of a sprint, but that is very much just the smallest aspects of an entire year cycle. So the 8-week sprint from sort of mid-June to mid-August is really the sort of the crux of the work, but there's an entire year long cycle, which includes defining the challenges, recruitment, which is parts of today's call, and then preparing data, getting everything ready so you are set to absolutely fly when we get into the thick of things. A little bit about that, so we don't just sort of suck our thumbs and come up with ideas. The challenge definition process is quite extensive. It starts from mapping out of the opportunity and solution space, setting up one-page kind of challenge templates, and a lot of you have contributed to that, which has been amazing. And then we have thematic workshops where we bring in sort of smaller groups to help refine those are initial ideas, a lot of work with the stakeholders, which ultimately come down to concept memos that then, in this particular case, ESA would be saying, these are the challenges we're going to run with. And then it's up to the researchers and the faculty to make the magic. In terms of the time frame that we're dealing with right now, I mean, we're right at the end of February, so we're hoping that we will be confirming faculty for some of the challenges in the near future. Then, very critically for this core, applications closed 31 March, so a month to go, and then we'll go through the process of all the application rounds and gets teams announced towards the end of May, mid to end. Obviously, there will be a lot of communication before that point. The sprint itself would start the 15th of June through to the 7th of August. I'll speak a bit more about what that sprint looks like, but it really ends in the live showcase, 7th of August. We take the foot off the accelerator a bit after the live showcase. There's a period of refinement where there is also a technical showcase. So live showcase is a sort of a TED talk style event, really trying to get that research at a high level out there, and celebrates what was done. But then there's a period to refine and dive into the technical details, which can then be presented to the stakeholders at a much more involved level. And then obviously we have the results handbook that we release, and there's always some amazing conferences at the end of the year where we see a lot of the research be out there in the public. So that's the sort of look at the high level timeline. At a more granular level for the sprint itself, so it's an 8-week sprint, as I mentioned. And the main things to highlight is that pre-sprint, there's a bit of a countdown phase where we will be doing quite a lot of onboarding for you folks, getting you up to speed, tool access, all of these sorts of things. We have a boot camp, which at the moment, until I can say anything different, is going to be an in-person boot camp for Earth Systems Lab. That is with our colleagues at Esrin, ESA, and then the rest of the sprint would be virtual. So the teams then move to a virtual format and work through towards the live showcase. That is the digital showcase on the 7th of August, within a bit of a cool-off period towards the technical showcase. Some of the things I would like to also highlight in this is that there's a very rigorous process involved with the sprint. It's not just sort of, here's data, here's your team, meet each other, and off you go. It's really set up to help you succeed every step of the way. So we have certain things like our FDL formal Fridays or F3 reviews, which are perfect checkpoints for you to make sure that you are hitting those progress milestones as one goes through. And it is something that is maybe not too familiar to a lot of us in academia. That's something that I definitely found when I was a researcher and faculty, but incredible to see that process deliver. And then, there will be a whole bunch of small deliverables along the way that when you get to the end, put it together, and it's amazing to see the end result. Briefly, in terms of the second half of the year, so we've talked about the kind of application, the sprint. Now, the second half of the year, you've done all this amazing research. Where does it go? Well, we're all about open science, first of all. So all these outputs are to be shared. We have the results handbook that we help you sort of tell your story, and we have an amazing design team who create content for that. But then there are also, of course, the end of year conferences and journals that are outputted. And also what's shown on the screen is Space ML. So within FDL, we are setting up a new service that is going to really champion open science and all of these outputs, the catalog of 10 years, 10, 11 years, to be available and accessible. The other thing that I really would like to emphasize is that FDL isn't just about the sprint. It's not just about the research. It's very much about the community. It's about really bringing your best self and the best people together and letting all that magic happen. So we cannot do this without our community, and we are always so excited to be welcoming new folks to join us in tackling the really important and difficult problems that the world is facing every year. So yeah, for me, this is probably the biggest benefits of FDL, is just joining this group of like-minded individuals who are all absolutely brilliant, coming from different parts of the world and their different domains, and really just being exposed to this is something incredibly special. I'll just leave it here for a moment. Some of our faculty from last year were kind enough to share some thoughts about what makes Earth Systems Lab special to them, and I would say that the resounding kind of take home is it is about the people, and when we get the right people together to tackle these really important problems, no problem is too big. So it is about teamwork. It isn't about being the lone wolf. Everyone is brilliant. Everyone brings their own different aspects to the team dynamic and to FDL, and that's what makes it incredibly special. So we would like to know about all of you. When you are starting the application process, please bear that in mind, that we want your authentic self. Please do not try and think, what is it that one wants out of this? We really just want you to be you, because that is what makes this amazing. And to be honest, it is also it's going to be tough. It's a serious challenge that is laid down every year for the research teams, and when the going gets tough, it's the colleagues in your team that are there to help you through it. So within that programming that we provide during the FDL sprint, it is also about fostering that teamwork and community, and we have an incredible collaboration coach, Lena Raffi, who helps guide us through this, and she's developed these 7 C's, so not the Atlantic, Pacific and that, but rather all starting with the C: the comedy, co-creation, courage, complexity, compassion, curiosity, and community. And all of these add to the experience and really help us navigate those difficult times and the challenges that come, and just have a lot of fun along the way. It should always be fun. So just before jumping in, and then welcoming Will to maybe share some thoughts, I wanted to very briefly look back specifically at last year's challenges for Earth Systems Lab in particular, just to give a flavor. So I also see that Yopi and I think a few others are on the call here. So the one team, there we go, was looking at foundation models in extreme environments, and really asking a very critical question now that we see foundation models are everywhere and large language models and all of these things. But how do we know that a model can be certain, and how do we help a model say, I don't know? So I would also like to give a shout out that this team came up with the best acronym, make foundation models say hashtag I don't know. But really looking into helping foundation models be more trustworthy and usable in all sorts of different responses. So what they were looking at, in short, and Yopi can definitely jump in here if I get this wrong. But looking at both the training data and the embeddings themselves, trying to understand if a new sample that a model sees is particularly different to what it is used to, and being able to flag that. You can think of it as a sort of a distance metric in either of those contexts, and being able to flag that this is something very new, very different, and that the certainty of a model predicting this new sample would be quite low, so high uncertainty. But then they went one step further and didn't just look at the sort of the data question, also looked at the model itself and the variances associated with the different model predictions. And obviously, the more variance, the more uncertain. And putting these two things together, suddenly we have this framework, Shrug FM, which another incredible acronym, allows a foundation model to literally shrug and say, I don't know. And this suddenly becoming incredibly useful for whichever downstream use case that you can have, say, floods or fires, which were the particular ones looked at, and other things like landslides, a simple extension on top of that, but suddenly being able to know when to trust your foundation model. Then, yeah, very briefly onto StarCop 2.0. So I mentioned them already in the context of the pipeline being used for the UN Methane Observatory. Well, this team last year went one step further to really take this on board and developed a pipeline for unauthor-rectified images. So typically we author-rectify an image so that the curvature of the Earth is sort of flattened out, and you have that lovely sort of post-processed image. But if you want to get information as quickly as possible, you need to be able to do your machine learning pipeline on board with the raw data, and the team managed to do exactly that with the vision of having a tip satellite and a Q satellite. The tip satellite being able to just have a very quick look at a sort of a multispectral level that there is an emission, and then the Q satellites in a hyperspectral context being able to actually sort of segment and find the exact concentration of whichever emission was around. And then finally, and this is to really tee you up for, is the 3D clouds for extremes team. So also building on some previous work and taking it further, using even more satellites to get a global coverage of clouds, and able to reconstruct the 3D structure of this with the various quantities of interest, so water content, ice content, these sorts of things. And the interesting application here is being able to do that in the case of a hurricane, which is shown over here on the bottom right. I've got an even better little video to do that, and I think I will. Yeah, let me jump into that, and then give you the reins, Will, to maybe just talk us through what are we looking at.
Yeah, definitely. So this came out of well, two projects research essentially. The first year we were looking at this challenge of taking, well, we have some of these satellites which have cloud profiling radars on board, which means they give you these fantastic views, slices through a cloud, but no spatial information. And we're saying, okay, what if we train a model to take that thin slice through a hurricane or another cloud and turn it into a full 3D reconstruction? And that worked surprisingly well. So we decided the next year, kind of combined with research that came out about how important these cloud structures are for the intensity of hurricanes and enabling these rapid intensification processes, we thought, well, why don't we take this a bit further and try and apply it to the globally across multiple different sensor inputs, and with a particular focus on hurricanes. And so here we're showing this storm Dorian that hit Jamaica and the reconstruction of it. And I think we were really surprised with how well it worked. So we're excited to see where that leads.
Yeah, incredible stuff. I think you even maybe underselling us. I mean, you managed to spin up the pipeline for Melissa as well, incredibly rapidly. So yeah, very, very cool stuff. And this kind of in maybe a next version, a real-time capability would be incredible to see. Okay, so that brings us very conveniently to some alumni reflections. So I know, Will, you've been involved with FDL for quite a long time, and I thought just to start things off, and also I'd encourage everyone, the Q&A session and the functionality that is here. So remember, bottom right, the 9 little dots Q&A is not just for me. You can also more than welcome to put Will on the spot if he says something that you want to question. But yeah, you've been involved for quite a long time, and in the various different sort of roles as a researcher, as a faculty. What was it that initially brought you to FDL and Earth Systems Lab?
Yeah, I was trying to think back to this. I think it was back in 2019. It was actually one of the challenge planning meetings was held at Oxford, and my supervisor, when I was doing my PhD, was going along. And he said, I thought you might be interested to come along to this. And I went, and it was a really fascinating insight to this process that, meeting FDL for the first time and bringing together a big group of experts and people working in the ML side and from industry, and really getting a kind of finger on the pulse of what are actually important challenges to look into and what can we actually do about that. So that was really interesting, and I paid attention to the FDL projects that summer. And then the next year, one of the postdocs in the group said, hey, I think you should apply as a kind of domain expert. And that was my project as a researcher in 2020.
Oh, yeah, amazing. And maybe just jumping on that, so like reflecting back on that experience as a researcher initially, obviously now you've been part of the program for a bit longer, but if you can sort of cast your mind back to that, what is the one thing you know now that you wish you knew then, and maybe as a young Will applying, if you could have said, here's a little heads up?
I think the main thing is don't pigeonhole yourself. Don't think just because you're a domain expert, you can't do the machine learning side of things. You can only work on the data and interpreting results, or just because you have a machine learning background, you can't, explore anything to do with the actual domain side of it. That I think I went in having never done anything to do with machine learning before. And by the end of that summer, I was working directly with the most ML focused research from the team who'd never worked with climate data before. We were working directly together, building a causal network model to try and interpret our results. And that was a really fascinating process of going from, it is a real kind of collaborative effort. It's not, you have a set job based on your background of the team, but really, think about what you can get involved with as a group.
Yeah. No, the growth potential here on both sides, it's amazing. And then maybe just for possibly some of the folks on the call who are interested as joining as faculty, if you compare your role as a sort of a hands-on faculty member to that research experience, what would you say is the biggest difference there between the two?
I think the immediate thing learning from going from researcher to faculty was kind of learning to take a step back. That they're really interesting problems and really fascinating to work from, but your role as a faculty isn't to solve it yourself, it's to enable the team of researchers to solve it. So kind of giving them the space and the freedom to explore the problem and come up with their own solution, and then kind of supporting them to do that. So I think I see my role as faculty is a lot of it being kind of dealing with and kind of managing any of the kind of things that would be distractions or disruptions to the team, that to allow the researchers to kind of focus on the core idea, and then anything like, oh, we need a different data set, go off and manage that, or kind of some other more admin side of things, we'll manage that, you focus on the research. And I think the other thing is just thinking a bit more about the interpersonal nature of the team. That fortunately we've never had any problems with people's personalities not working, but people have different ways of working. You need to accommodate that. And something you can do as faculty is make sure that everything is working for each member of your team as an individual, and also looking out for each other. That sometimes it's a high pressure research sprint, kind of just keeping an eye on seeing how people are doing and letting them know they're supported if they're feeling stressed and under pressure.
Yeah, absolutely, and absolutely embodied that. Seeing you lead the team there. A last question from me. I do want us to get to the general Q&A, but maybe what was the most surprising thing that has come from your involvement, and possibly like if any of those bits have continued to your now day-to-day outside of FDL?
I think probably one of the most surprising things coming in was just how important and impactful the work done during the FDL research sprint is to everyone involved. I think I came in from the domain side thinking these are problems very relevant to my research outside the FDL, but maybe someone coming in from the machine learning side would just think, oh, it's just an interesting application of something I do, but not what I'm really interested in. And I remember that first year being involved, a researcher from DeepMind saying that this, I think it was one of the advisors saying that this is the most interesting project he's been involved with, isn't it, in his career. And that kind of struck me, that actually what we're doing here is pretty special for everyone involved. So yeah.
Amazing. Well, thank you so much. We'll get to the Q&A bits in the end. So if you still have some time, it would be great to have you join with that. I'm going to get us through to that point. A few last things, a bit more on the application side as well, or not application, but your applications. All of these bits, please feel free to have a look at the Earth Systems Lab website as part of the FDL AI family of websites. So ESL Lab or ESLab.ai. There you'll find all the bits we were talking about, the different research over the years, importantly last year's technical results and findings documents, the live show guest recordings, and then also obviously application information and timelines and the facts as well. In terms of the applications, they are open. Please do apply at eslab.ai/apply. The QR code on this particular slide will also take you there. The applications, first deadline to note is that they'll be closing on the 31st of March. We do encourage early applications. The earlier we get your application, the earlier we can move forward with it. I'll just say also that the applications for our sister programs are also open, and you can please feel free to apply to those. They obviously have a bit of a different domain sort of theme to them, but very much it's still the FDL program ethos that follows through. Just also to note, ESL is a program predominantly for PhD and postdoc level researchers. That is predominantly so. It's not necessarily a given, so please do share your experience as well, particularly coming from a more computer science background. I am very aware that a lot of folks at master's level have had a lot of experience and would love to hear from you. But it is not a undergrad research opportunity is the emphasis here. Also importantly, researchers and faculty do receive a stipend to support the participation over the sprint. The sprint itself is 8 weeks, mid-June to mid-August, and the outputs thereof very much are aligned with publications and such. So I know within particularly academia, publications are a commodity, and we understand that entirely. It's not that the research is closed off. And of course, with this, you are going to meet folks from all sorts of different institutions and different partners, in particular ESA being the main stakeholder here, but also our industry partners at Google and NVIDIA will be very much joining. Into the very technical bits of the applications. So there's the initial online application, which you can follow this QR code again on this slide. It will take you there. Progressing through the online application will be a short cultural interview. So as we've heard, it's all about community, it's about teamwork, interdisciplinary science, and that also means that sometimes one is stepping out of one's comfort zone. So there's a short cultural interview. Progressing through that is a technical interview that would align to either your domain expertise or your ML AI capabilities. So I just want to note here that progress through the different application rounds is not necessarily a reflection on your potential or that. It's more about your fit and the alignment with the current research cycle. So please let us know if anything has changed since the previous application. We do keep the applications year to year, and the talent pool is recorded. But yeah, if your experience is slightly different to a research cycle, but another opportunity comes up, as mentioned, the FDL Med and FDL Flight Lab could be possible programs spinning up, then we were able to reach out with those. Final selection as well after the technical interview happens after confirmation of those research challenges and the faculty teams. So the faculty teams are very much involved with that. And again, it's alignment with the specific challenges that is the main factor in final selection. So I just want to make that very clear, and one should not feel that not making it through to final selection is a reflection on your potential. It is very year-on-year dependent. And yeah, also with that, your final round candidates will remain in the talent pool for future considerations. So that is always there. I am going to move swiftly through the facts that are on the website. I'll just say when you apply, you'll see sort of a question around what domain you feel you fit in. Are you a subject domain expert? Are you a software engineer? Or are you an AI ML expert? And I know a lot of us are all-rounders, but please do kind of think carefully about which one resonates the most with you and which one you would associate most with, because it's incredibly useful in terms of assessing a team structure. We can't have a team just made up of domain experts, for example. The sprint itself, as I mentioned, there would be you can think of it as a bit of a hybrid sprint with an online component for the actual sprint, but a boot camp that is in person for Earth Systems Lab. If that changes, we would communicate that as soon as possible. And again, here, if you are unsure that you meet all the criteria, please do still consider applying. We really want a diverse range of people to be joining us each year, and it's that richness of our community that makes us successful. So please don't feel that is inhibiting. But do realize, please, that this is an incredibly competitive program. We have hundreds of applications coming through, so it will be a prioritization for alignment with the actual research challenges. Lastly, I want to just note that the sprint itself is a full-time commitment for the research teams in particular. And the research often doesn't stop just at the end of the 8 weeks. There is always the possibility to continue with your team working towards whatever outputs you're wanting to. And yeah, there's also other ways you can get involved if the research or faculty roles are not what you are able to commit to or interested in. I would like to highlight there that reviewers, as part of the FDL process, they are incredibly useful and really help us deliver at that high standard that we want. All questions today as well will be collated and converted into facts on the website. So that is very much why we're running the Q&A in this format. So with that, I think we're going to open up for the Q&A session. So I believe there are already quite a few around, but please do feel free to add more in the Q&A. So on the bottom right of your screen, the 9 little dots, click on that, get to Q&A, and you are able to also upvote other questions on the slide as well. For completeness, there is the QR code for the application. Okay, so I'll quickly get the Q&A up here and start going. So from Anonymous, what would be the best way to prepare for the technical interview? Okay, that is a good question. I think from my perspective, we are wanting to see the most authentic version of yourself within all the interviews. So what I would love to see from my perspective is real use cases that you can demonstrate with a bit of coding experience that you have. You do not necessarily need to be a ML expert, but this is very much a computational research challenge. So being familiar and able to articulate some of your experience with coding would be incredibly useful. If you're coming in from a domain expert perspective, it would be showcasing that as well. So yeah, I wouldn't say it's something like go and cram lead code for days to kind of pass. It's really, we want the most authentic version of you when we stuck it in it, and once sprinting to the finish line. It is quite an intense environment. So yeah, well, one just wants to make sure that everyone is able to feel comfortable in that. But importantly, please do come prepared to share actual examples of work and walk the technical interviewer through that. I would say is the main up here. Let's see. Okay. How much is the stipend? Straight into the main question. So that is to be determined. To be honest, it is not decided by FDL. It is very much decided by the partners. I would say that it is generous and comparable to a sort of a postdoc salary in some cases, but that's, I realize, is a bit of a throwaway statement because there's so much variance in that, but it is generous, and we would be able to communicate that once we have confirmation. Okay, how many people for Earth Systems Lab are you recruiting this cycle? That is also a great question. So for this year, the Earth Systems Lab at the moment will be 3 challenges with 2 faculty per challenge and 4 researchers. That's the setup. There is the possibility that there would be additional challenges that will be brought on. There's always discussions around which sort of core ESA directorates would be involved, and there's the possibility of additional challenges coming in. And then, yes, okay, who owns the results? So within this, there is very much a push towards open science. So your results are very much open, and that is dictated as well by the funders themselves. There has to be appropriate acknowledgement throughout, both to the funders and the partners, and then to the program. But that's the level of ownership needed. Derivative products of it as well. That is a discussion to be had. And let's just see if we go through. Okay, so maybe just a follow-up, I guess, from the previous. For PhD students applying as domain experts is showing their PhD research sufficient for the technical interview. I would say yes, absolutely. A PhD sort of set of, I guess, a portfolio of work would be more than sufficient if it is at the right level and is relevant to the particular research challenge. Okay, another one. Okay, how many hours of work per week are we expected to provide? This would be for a researcher a full-time equivalent 8-week period. So that is your sort of 9 to 5 in that sense. I will say that it is a sprint and that there is a very clear deliverable associated with that. And what we do want is applicants who are passionate about the work that we do, the impact that is possible, so that when one is pushing towards that deliverable and things aren't working and there has to be some serious debugging happening, that one doesn't just sort of check out at 5 and say to your teammates, that's it, it's great, I'm clocking out. That is not quite how we see this. It isn't a typical job in that sense. It really is how do we do the best work possible? How do we do world-class research in this time? And a lot of it comes to working as a team, but also being there for your team members. Okay. I'm looking if there's any Q&As for you, yeah, Will. If you see any, do shout. Okay, I'll quickly go through FDL Flight Lab. Yes, this is a program that is still under consideration. It would ultimately be focusing on aerospace and aerospace engineering. There have been some challenges in the past focusing in that, and there's the possibility of spinning this up into a program in itself. I would say that this is something to kind of watch the space. If timing doesn't come to the point where we can run the full application cycle, then it would follow on until next year. A question here around is it a disadvantage to be more of an all-round or hybrid rather than an ML domain expert? It's a really good question. I would say no. Within a team, you need the full spectrum. You need experts on either side, but importantly, you need some folks to be able to work on both sides of that fence and to actually translate concepts across from domain to the ML side. So absolutely would be a huge advantage if you are an all-rounder and a hybrid rather than just a ML or domain experts. And please, when you apply, bring that to life where you feel that you are able to contribute. We really do want to see all of those aspects come through. Okay, so here's another question around the boot camp. Only the boot camp being in person. Yeah, so it is something that is I guess a product of COVID, when we had to move a lot of these in-person components online. But yeah, one of the benefits of being online is that one is able to work with folks from all over the world and from different time zones and different life stages as well. So the tooling we use is very much geared towards virtual collaboration, and that's been very successful. It is incredible to have the boot camp in person, I must say. So really great to be able to meet everyone in person and then move to that online aspect. If there are folks that are co-located, there are typically quite a few meetups throughout the sprint, but also afterwards. So in the UK, there's definitely a bit of a nucleus around Oxford. We based at the moment here in London, but for instance, University of Valencia has had quite a hub last year, and folks are able to meet up, and one would really encourage that. And then, yeah, confirmation around the in-person boot camp being mandatory. And does the location impose constraints? So this is something to discuss. It is highly encouraged, and there may be an exception made in very special cases, but otherwise it is mandatory. And yeah, we can definitely discuss whether there are any constraints imposed by that. So this is typically in Frascati in Italy, and if visas and such are an issue, it's something that we would have to discuss. Is the opportunity open to industry research engineers who do not necessarily have graduate degrees? Absolutely. So this is to the point earlier that just saying the kind of postdoc and PhD level is to emphasize that it's not a undergrad research opportunity. This is very much a advanced sort of research opportunity. And if you are doing research in industry, you probably come with an incredible amount of skill that's and experience that can be beneficial to the research. So yeah, please do apply, and please do articulate that. Okay. No postdoc positions here. The deadline for the research sprint application is the 31st of March. Okay, and going down here, I think made it to the last Q&A. So just in terms of the question here, okay. What I'm getting out of this last question is around a subject domain expert that does some machine learning / deep learning techniques, but not necessarily deep dive into that, and what would the level of technical expertise be with regards to that sort of programming or AI proficiency. I would say that this to me sounds like quite a hybrid kind of role, where one is fluent in that programming / AI proficiency, but not necessarily an expert, but you do also have the domain expertise. So yeah, please do articulate that, and then that sounds very appropriate as well. Okay, I think, yeah, we've got through all the questions. Well, thank you for joining us this afternoon and making the time, and really looking forward to seeing what 2026 holds in store. From my side, thank you very much for joining us this afternoon, and hope to see you all very soon.